Hello everyone, myself Abdul Adib. Welcome to our podcast. The topic of our podcast is the breeding objectives and the crop improvement aspects of banana. Before we dive into our topic, let me introduce our amazing team members, Mr. Kunal Thakur and Mr. Nikhil. So the different aspects of our podcast we're gonna discuss is like the introduction and breeding objectives and crop improvement approaches in banana. So basically, the cultivated banana is botanically called as Musa paradisica. It's a cross between two wild species, Musa acuminata and Musa balbisiana. And the chromosome numbers, the basic chromosome number of banana is 11, and the somatic chromosome number of banana is 22.
I would like to add few points to the introduction. The fruit type of banana is berry, edible part mesocarp and endocarp. The bearing habit is terminal old season growth. Inflorescence spadix, which is a special type of inflorescence in banana.
So Adit and Nikhil, I would also like to add some information to the breeding of banana. The breeding of banana was started in Trinidad in 1922, West Indies, and in Jamaica in 1924. According to Simons, the edible banana is native to Old World, especially Southeast Asia. Now, if we talk about the Indian scenario, the Musa acuminata was introduced to India and Burma, where Musa balbisiana was a native species.
So now we will discuss about the breeding objective for banana. Production of good quality fruit suitable for export, developing longer finger size.
I would like to add more few points with respect to objectives of banana, like development of a dwarf statute structure. As we all know that the more will be the height, the damping of the banana will be the probability. So the dwarf statute structure is the breeding objectives of banana, and it is most preferably to the high density planting. And as we all know that there is a chance of high wind velocities in the field, and the development of resistance to the biotic stresses such as disease resistance such as Moko disease, Panama wilt viruses, and Bunchito virus.
So I would also like to add some of the breeding objectives for banana. The development of varieties with wider agroecological adaptability, and the development of male fertile parthenocarpic diploids, which are resistant to the major disease and pests for banana. So now we will discuss about the different crop improvement approaches for breeding in banana. The 4 different types of breeding approaches that we will be discussing are namely introduction, selection, hybridization, and mutation breeding. So let's begin with introduction. So introduction of some cultivars of banana was made with resistance to biotic stresses. For example, ladyfinger, which is resistant to bunchy top virus in banana, was introduced from Australia and is being currently evaluated at IIHR Bangalore and TNAU Coimbatore. Furthermore, some cultivars like Nani MS from France and Villeri from West Indies were further introduced for utilization in improvement of programs for breeding in banana.
So guys, I will be discussing about the hybridization work done in India. Okay, so basically in banana, like the breeding was started at the Central Banana Research Station at Adutai. It was in 1949. So I will be discussing about the most prominent institutes in banana, where it's situated in India and world. Like it is in INIBAP. It stands for the International Network for Improvement of Banana and Plantains, which is situated in France. And the other prominent institute which is related to banana breeding, it's IITA, International Institute for Tropical Agriculture, which is situated in Nigeria. The other most important is the National Research Station for Banana, which is situated at Trichy in Tamil Nadu. It has a 597 accessions of banana. And when it comes to pollination in banana, pollination is most probably done in the morning, where the female buds are bagged and pollinated. The first crop in the banana takes a longer time, basically from 15 to 19 months, and the seeds are extracted over there, and it is being planted in the polyhouse. So when it comes to the breeding hybrid varieties which are developed in world and India, there are few varieties I will gonna discuss in India are BRS1 and BRS2. When it comes to BRS1, it is cross between Agnivore and Pisang Lily. Agnivore is a female parent, and Pisang Lily is a male parent. The basic objective of the BRS1, developing the BRS1 variety, is the resistance against the Sigatoka leaf spot. And when it comes to BRS2, it's a cross between Vanna and Pisang Lily. Basically, it is develop resistance against the Panama disease. When it comes to other varieties when developed in world are the Peta 9 and Beta 3. Peta 9, the basic objective of developing the Peta 9 is the resistance against the black Sigatoka resistance.
Let's discuss about the mutation breeding. Bird mutation in India. Banana is a very common paraphase due to spontaneous rearrangement of chromosome in a somatic meristem and structural rearrangement. High gate of AAA is a semi-dwarf mutant of gross picture AAA. Mota Puan AAB is a spot of Puan AAB.
When it comes to selection, as we know, best selection is a process where the number of cultivars are grown together, and the superior one is being selected out and being cultivated separately, so that it has a better characters such as disease resistance, pathogen resistance, and all dominant characters. So basically, the major selection cultivars are the dwarf Cavendish, Robustus, Mota Puan, Nendran, Red Banana, and so on.
So through this discussion in our podcast, we can conclude that banana breeding aims to tackle the various industry challenges like disease, yield, and quality of the fruit. This can be tackled by blending the traditional methods with the biotechnology. So this approach accelerates the development of resilient high-yield varieties, which are crucial for the sustainable agriculture and global food security. Finally, we would like to thank our course in charge, Dr. Praveen Verma and Dr. Shailesh Kumar, for providing us this wonderful opportunity. Thank you.
Thank you so much.